Here we'll go through some examples of base conversion. So remember, with working in other bases, some of the important things to keep in mind is that the digits that we see should only ever go up to one less than what the base is. So in base 10, we only go up to 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go 1, 0. So in base 2, you've only got zeros and ones. So two symbols, only up 0 and 1, and then the number 2 is represented by 1, 0. In base 5, the number 5 is represented by 1, 0. So you only go up 1, 2, 3, 4, and then the next number you go over to is the 5. So for doing these types of questions, it's similar to time conversions, because time conversion is essentially just base 60 conversion. And the easiest way is first to set out your columns and your place values. So with 2's, we've got our base unit, then the next is worth 2, because remember, we're counting up, we go 1, and then the next one will be 1, 0, so that means the number 2. 2 here, and this column is worth 1. We then go 1, 1, that would be our number 3 in base 10, and after here we've run out of symbols, so the next number we're going to go up is 1, 0, 0, that's worth 4. And it keeps on doubling, because the next time we'll go up another column will be when we're at 1, 1, 1, that's equal to 4 plus 2 plus 1 equals 7, so our next column is worth 8. So we go 8, 16s, 32s, 64s, 128s, 256s, etc. So when we see a number like this written in base 2, we can just set it out. So the 0 here is in the units column, the 1 is in the 2's column, there's a 0 in the 4's column, a 1 in the 8's column, a 0, and a 1. And so in calculating what this comes to, we just need to recognize, okay, so we've got 64 plus 8 plus 2, and this equals 74. And more precisely, 74 in base 10. When we're going to 5's, it's a little bit more difficult, because in 2's we only either had something or didn't have it. So we had 0's and 1's. With 5's we can go all the way up to 4's. But the idea is still the same. So with 5's we're going to be counting, we go 1, 2, 3, 4. Then the next number across is 1, 0. So that means one lot of 5 and 0 1's. The next time we change columns, we're going to be at 4, 4. Which means 4 lots of 5, which is 20, and 4 lots of 1 is 24. So this 1, 0, 0 is equal to 25. And then again, once we're up to 4, 4, 4, that means we'd have 4 lots of 25, which is 100, 4 lots of 5 is 20, and 4 lots of 1 is 4. So from 124, next we're up to 125. So each time we're going 5 times more. So we've got our units times 5 is 5, times 5 is 25s, times 5 is 125, times 5 again is 625. How many places do we have to go up? 1s, 5s, 25s, 125, 625. So here we've gone far enough. So this is the number 4, 3, 1, 3, 2. And now, rather than just adding them together, we need to do a little bit of multiplication here. So we're going to have 4 times 625 plus 3 times 125 plus 1 times 25 plus 3 times 5 plus 2 times 1. And so we can calculate these. So 4 times 625 gives us 2,500. So we've got 2,500 plus 3 times 125 is 375, plus 1 times 25 is 25, plus 3 times 5 is 15, plus 2. So here, putting these together, 375 plus 25 is 400, plus 2,500 is 2,900, so it's going to be 2, 9, 15, and 2 is 17, and that's our number in base 10. So it's basically just work out what each of your columns are worth, multiply them out, and then this will give you your base 10 number. And remember, this isn't really any different to what we have in base 10s. Because if you have the number 376 in base 10, what this means is 3 times 100 plus 7 times 10 plus 6 times 1. So it's just separating those columns into their values worth. It's just that with base 10, we have these nice, well, in our system they're nice, multiples of 10, whereas in other bases you've got multiples of 5 or multiples of 2 as it is. Now going in the other direction is a little bit more difficult. As you would have noticed with time conversions as well, if we're going from hours, minutes, seconds into seconds, we can just multiply it out. But if we're going from an amount of seconds and trying to represent it in hours and minutes, it's much more difficult. But basically the question is, so here if we've got 279 and we want to represent it in base 2, the question is, how can I represent this number using only multiples of, or powers of 2. So 1s, 2s, 4s, 8s, 16, 32, 64, 128, 256. And that should be large enough because the next one would be 512 and that would be too much. So how can I represent this number using only, think of these kind of like as your currency, represent each of them represents some kind of amount of money or some dollar bill, and we want to make up that number in basically as efficient a way as we possibly can. Okay, so the idea is we start from the top in this case, so 279, 512 would be too big, but we do want to use this 256. And then the question is, if we use that, how much will be left over? So we need to do a little calculation. So 279 minus 256 gives us how much left over? Just 23 left over. And then how do we make up that 23? Well, we don't need the 128. 64 would be too big, 32 would be too big, but a 16 we can use. So now we go 23 minus 16, and this gives us 7. How can we make up the 7? 8 is too big, but we can use a 4. So minus 4 gives us 3. We can then use a 2. So minus 2 gives us 1. And then lastly, we can use the 1. And minus 1 gives us 0. So here we're just calculating basically our remainders. And how do we represent this number? Well, in base 2 we either used something or didn't. So here it's just 1 for the 256, 0 128s, 0 64s, 0 32s, 1 16, 0 8s, 1 1 and 1. So this is my number represented in base 2. We can also write it if we want as a little 2 here, but probably for the moment to keep everything explicit we'll just write it in base 2. So when we're going to 5s, we're essentially doing the same thing. The only difference is we can use more than one of each of those multiples. So with 5s we're going to have 1s, we're going to have 5s, 25s, 125s, 370 after 125 is 625s, times 5 again gives me 3 125s, and then after that I'll be up to 15,000 I think. So 4 times 25, so times 5. So that's my, sorry, that's not right. So 5 times 625 gives me 3125, and then if I multiply that by 5 again, I'd get 15625. Okay. So 15625 is going to be too many. So here, the way that we calculate we'll probably keep a little bit more track of. So 15,000s is too big, but what I can ask is 3418 divided by 3125, and what it gives me is equals 1. and how many left over? I need to work out the remainder, and so the remainder is just going to be my 3418 minus 3125. Do all of this, don't need to do that, so 3, calculate here, 9, 2, so 293. So the remainder, as I'm writing it in, is 293. Okay, so I had 1 here. Now I can keep on going. I'll just put this as working over here. It's not working. Okay. So now, the next question we ask is how many 625s do we need? So here we go, 293. How many 625s? And we've got 0. How many do we have left over? The same amount. So we've got 0 left over. So this is kind of what we were doing with the binary case, but it's just a little bit more difficult here because we could have more multiples, but we can move on. So again, using our 293, how many 125s do we need? And we can use 2, because 2 times 125 is 250. And that would give us, so now we've got 293 minus 250 equals 43. So now we've got a remainder of 43. And then, so we had 2 here, and then we've got 43. How many 25s? We just get 1 because 50 would be too many. And what's the remainder in this case? 43 minus 25 gives me 8 and 1, so 18. Make up 18, so I have to write in the 1. So make up the 18 with 5s. I get 3 and 3 left over, and then 3 divided by, so my 3, and then 3 divided by 1s equals 3, remainder 0. So this ends up being my number in base 5. And no matter what base I was doing, I could do it in this way. So basically just each time we start with our number, how many of the denomination we're looking at, we'll get this is what we represent in our columns, and then this is how many we have left over. So when we go to here, that we then continue on with the process. So we're doing this over and over again. It's essentially just long division. It's like a form of long division. Okay, I hope you have fun with this. Remember, one of the activities for this topic is to see whether you can make a program that actually does a little bit of this. Maybe you wouldn't be able to do it for any length digits, but you might be able to do it for 1, 2, 3, 4, or 5 digit numbers, and it can help you create numbers that you can check. Okay, good luck.